they're all like little cogs working together and creating this continuous flow. The ITCZ in here, but I've also just expanded it out for the whole world, and that is what's happening across. And then that whole thing is driven up towards the west-northwest, and that polar low, which forms, that's pretty safe all summer, so you could jump up from the Faroes earlier on in the summer. But once you're around that into Cape Town, you're then picking up that St. Helena high, which is going anti-clockwise in the southern hemisphere, and that allows you to bring you across to St. Helena. Good evening and hi everybody. So the goals of our live session, we're just going to have a little brief overview of the following. Global circulation we'll start on. Then that'll bring us into the global winds that we experience. We'll touch on air masses because I felt that it kind of fitted into this kind of topic quite well, before we get on to ocean currents and global routing, which are a result of this global circulation and winds. So yeah, some really interesting stuff. However, before we start that, and this will hopefully be basic knowledge to you all here, but I thought it's worthwhile just touching on it because we do come across it quite a lot in our day skipper course. But wind is named where it comes from. So there's a few examples up there, and I'm not going to read through every single one of them. But if we say we have a westerly wind, that means the wind is coming from the west. And this all comes from historically, if we had a Saharan wind, it was described as such because it was coming from the Sahara. So kind of in ancient times, sailing around the Eastern Mediterranean, they quite often talk about having an Egyptian wind, and it was coming off the Egyptian coast. But yeah, some other examples in there as well. Yeah, worthwhile just having a quick browse. Global circulation. So I really like this kind of overview look at it because it helps us understand why we experience the weather and the winds we do. So this kind of builds up. I wasn't quite sure the best way to do it online. I would generally always just use a whiteboard and draw it on the whiteboard. So I thought, well, I'll just try and do it in stages online. And hopefully it comes out all right, and hopefully it makes sense to you all. So what we have here is we have a picture of the Earth, and yeah, showing you where the equator is. What is happening to us is the sun is sending its rays our way, and it's trying to heat up the Earth's surface. Now, what happens when the Earth's surface heats up? Well, hot air rises, and it heats up the equator the most, mainly because there's actually quite a lot of land around the equator, certainly for half the world anyway, but also that's the area that's closest to the sun. So as this hot air rises, it rises up off the Earth's surface, but once it gets to the top of the troposphere, which is the layer of atmosphere that we are in and breathe and our weather occurs in, it can't actually go any further upwards, and so it has to start going outwards. As it starts to go outwards, it eventually cools because it's at a much higher altitude than the surface, and the temperatures up there are just much cooler. And so the cool air falls, which is the opposite of the hot air rising. And as that cool air falls, it pushes down on the surface of the Earth. It has nowhere to go, so it goes outwards. And it's doing this in both hemispheres. And then the cycle continues. It creates this kind of cell, basically, this kind of circular, it's not circular, but this continuous motion, and this is known as a Hadley cell. You don't really need to remember that. It's just a nice little bit of information. Okay, so back to how the sun is heating the Earth. The sun's rays are coming in, and as I say, they're heating the equator and the hot air is rising. But up at the poles, the sun's rays are coming in at a much more oblique angle. So they're not only coming in at that finer angle and reflecting out and not being kind of kept in that troposphere, in our atmosphere, but also the poles, as I'm sure you're aware, white, which is a reflective surface. So that's reflecting all the sun's heat. It's making that area super cold, and so the air isn't warming up. So we've got cool air, and the cool air is falling down, and again, it's got nowhere to go, so it has to go outwards. And so what we now have is we have cool air traveling from the poles to the equator, and we have warm air traveling north from the tropics up towards our poles. They eventually meet, and they create this kind of battle zone. It's warmer air meeting cooler air. All that results in kind of warmer air. There's nowhere else for it to go, and it has to go upwards, and then it meets the top of the atmosphere and goes outwards again and creates two more cells in our atmosphere. Now, if you go back to thinking your basics of latitude, we've got 90 degrees of latitude, we've got 3 cells. It stems to think that these 3 cells are roughly, in theory, 30 degrees each. So the point at which the Hadley cell, that's between 0 degrees and 30 degrees. And then the next cell, the ferrule cell, is between 30 and 60, and the polar between 60 and 90. Now, that's just a theoretical. It does move around a little bit as the sun's heating changes throughout the year, because our Earth is on a tilt. Now, I've just drawn in where our high and low pressures are formed here, and that is because of the falling of the air pushing down onto the surface, but also the rising of the air. So where the air rises away from the surface, we have semi-permanent low pressures, and where the air pushes down onto the surface, we have semi-permanent high pressures. But yeah, these essentially move around, but are always in that kind of position of the Earth's surface. Now, in the Northern Hemisphere, the high pressures circulate clockwise, and the low pressures circulate anti-clockwise, shown by the little pink arrows. And when the wind, or the air flows, is probably the better term, when the air, it tries to flow from the high to the low, which you could always see as how the circulation in the cells are happening. The arrows in the cells are going from the high to the low. But on the surface of the Earth, that's allowing the airflow to travel from the high to the low. However, it doesn't just travel directly north to south or south to north in a straight line, directly from high to low, because of the Coriolis force. And that's due to the Earth's rotation. In the Northern Hemisphere, when the air is flowing south, it bends to the right. And when it's flowing north, it bends to the right. And in the Southern Hemisphere, when the airflow is flowing north, it bends to the left, and when it's flowing south, it bends to the left. And that's all due to the Coriolis force. So you can see that that's what's happening here on either side of the equator in the Hadley cell, and that is the creation of what we know mainly as our trade winds. And we step it up one more in that Northern Hemisphere, from the high to the low in that 30 to 60 degree latitude. The winds bend to the right, and we then have what we kind of know as our kind of westerly flow, which interacts with that low pressure above it. And then finally, we have these winds coming from the high to the low up from the polar cell, and they are known as our polar easterlies. The same thing happens in the southern hemisphere for those as well, and we'll see that in a little minute. Everything kind of links up. So if you imagine the wind, and if you just look at the northern hemisphere, that the circulation of the low and the high is kind of linking these airflows between the cells together. So they're all like little cogs working together and creating this continuous flow. But at the equator, that doesn't happen because the winds aren't coming in to mix, and there is no kind of low pressure system on the equator. There's just a low pressure. And what that creates is the ITCZ, which stands for Intertropical Convergence Zone, also known as the doldrums. So areas of light winds, lots of thunderstorms, especially later in the day, and yes, squally conditions, rather than a consistent wind, which we're seeing either side of that in what is known as our trade winds. So yeah, I'll just get you have one last little look at that before we kind of put it out onto, that's looking at it on the curved surface of the Earth. Let's look at that on the flat surface of the Earth. And I've just done it for one ocean, or one kind of strip, basically, to begin with. And if we start, let's start at the top and work our way down. That's the easiest way. At the top, we've got those polar easterlies. So they're coming out of the polar high and towards the low pressure, which at the moment is sitting south of Greenland. And that's known as our polar low, circulating anti-clockwise. The next one down of the pressures is the high pressure, the semi-permanent high, which in the Atlantic is known as the Azores high. As you can see, it's sitting on top of the Azores there, creating a clockwise motion. And between the Azores high and the polar low, we've got those kind of that westerly stream, and that's what's picking up the low pressures, bringing them across and throwing them into the UK and giving us all our lovely wet and windy weather. South of the Azores high, then the airflow's traveling south again, bending to the right, and that is known as our trade winds. East-northeast winds all across the tropics. They're pretty steady, and they, in theory, will blow that direction for most of the year. Then you've got your ITCZ in the middle, not labeled. And then you've got your trade winds in the southern hemisphere, the South Atlantic, coming from the southeast. Your St. Helena high is the semi-permanent high in the middle of the South Atlantic. Then we've got our west-northwest kind of winds that are pushing and driving the Southern Ocean low, known as our polar low again, before down on top of Antarctica, which isn't shown on this chart here, is our polar easterlies again, this time coming from the southeast rather than the northeast. And I think Tom was a little shocked when he had a look at this earlier on. So this picture just gets a lot more complicated in a minute. And we just extend that out. And so I've added the ITCZ in here, but I've also just expanded it out for the whole world. And that is what's happening across our oceans in the world. The same thing that we've just described in the Atlantic is happening in the, well, to the left would be the Eastern Pacific, and then the Indian Ocean, and then the Western Pacific, kind of to the east of the Asian continent there. The whole process is the same, and yeah, everything's kind of working from this system, and that is all built up from that heating of the equator, which creates that rising of the air, and also the cooling of air at the poles, which is creating the falling of the air. And that then creates the cells, and I'll just jump back 2 slides just to remind you what it was. The heating on the equator starts off the Hadley cell, the cooling on the pole starts the polar cell, and then the mixing of it all creates the feral cell in the middle. On the southern hemisphere, the cells are named the same. So going downwards, you'd have the Hadley cell, the feral cell, and then on the South Pole, the polar cell. So yeah, hopefully that was a nice little brief intro into how these global winds are kind of working with each other. Now, I'm just going to take a little, it's still relevant to what's happening and what we're talking about, but just going to take a little slight tangent here and talk about localized air masses, because we were looking at the big global model, but then these global models, as they bring air masses towards the continent, depending on what direction they're coming from, we can describe how that air mass is either going to affect us, depending on where we are in the world, and what kind of or what the properties are of the air mass. And we can break that down to, if the air mass comes from the polar regions, it's going to be cold, self-explanatory. If it comes from the tropical regions, it's going to be warm. If it comes from the maritime, so that's off the ocean, then it's going to be wet. And if it comes from the continent, it's going to be dry. That's because there's no evaporation from the Earth's land surface to bring the moisture into the air mass. If it comes direct from the Arctic or Antarctic region, it's going to be super cold, not just cold. And if it's in that equatorial region, as I said, the ITCZ, the doldrums, then it's going to be an unstable air mass, just because of that massive heating effect, which creates towering cumulonimbus clouds and squalls. And like we do when me and Tom were together earlier in the summer talking about all the different cloud forms, we can put these words together again. Tropical maritime is warm, wet weather because it's coming off the Atlantic. Polar maritime is cold, wet weather because it's coming from the North Atlantic, where the waters are much colder. And Arctic maritime is super cold, wet weather because it's just coming straight down from the poles. So they're the kind of ones we'd experience. And you can think about how our weather, or where our winds come from on a daily basis, and how that might change. And the tropical maritime and the polar maritime is a very good one to think back to the frontal systems. The tropical maritime is the warm front, and the polar maritime is the cold front. And just think about how that works with that. For those that are maybe listening on a future recording of this, or are already up nice and early in the United States and with us, then they've got a few extras coming down off Canada and the northern regions of Canada, or into Canada itself as well. They have Arctic continental, so yeah, super cold, dry winds and weather and air mass. That kind of northwest of the States, Western Canada, polar maritime, cold and wet. Southern California type area, warm and wet. Coming into the States from Mexico, warm and dry. And coming off the Caribbean into the States, warm and wet. Kind of thinking like hurricane type weather. Up in the northeast, kind of Newfoundland area, cold and wet, polar maritime. And then up into them, like the Great Lakes and that kind of area of Canada, they're getting polar continental, so they're getting cold and dry. So that's why that kind of northern, western, not quite on the coast of the States, your areas of like Chicago and stuff like that, they get much cooler weather because it's that cold, dry weather that's coming in. And we can do the same for elsewhere in the world. So we can do the same for Asia. I'm not going to go through every single one of them. You can kind of have a little look at the picture how it's coming from, but there's a couple of differences. Arctic continental, there's a lot of it coming down into the central area of Asia because the continent mass is just so big. So you've got lots of cold, dry air coming down from the north. You've got lots of cold, dry air coming from the west-southwest because you've got that whole Middle Eastern area plus the continent of Africa sending all that dry weather up. And then the other one, because the Indian Ocean almost, starts at the equator, or certainly does in the equatorial regions. There's no real North Indian Ocean. You're getting that maritime equatorial coming up as well. So you've got unstable and wet weather coming up and into that kind of southern reaches of Asia. That's kind of into India, Bangladesh, Pakistan type thing. And I think if you look up the 10 wettest places in the world, then something like the top, 3 out of the top 5 or something are in that maritime equatorial region of Bangladesh and India. As much as we might feel for us that are up in Scotland that Scotland is the wettest place in the world, it isn't. So yeah, hopefully that gives you a bit of an understanding. But let's get back to the global scale now and have a look at global currents. So I've just started off with all the currents into the picture here. And the reason I've done that is because the currents are driven by the winds, and we already know what the winds are doing. So if we look at the currents here and just kind of focus on the Atlantic, for instance, then if you picture where the Azores high was, you can see that the currents are circulating around that in the same way as the winds would in a high pressure. North of the equator, you've got that east flowing trade wind. Way up in the north, you've got that polar easterly coming down the eastern side of Greenland, and going all the way across the top of the North Atlantic, you've got that westerly airflow as well. So all of the ocean currents are getting driven by the winds. What we've got here is red is the warmer ocean currents, and blue is the cooler ones. And again, you can see ocean to ocean, there's a little bit of similarity between them. The reason that you might look at that and think, well, how is there a cold current going across the Canaries? Well, what's happening there is because all those northeasterly trades are blowing all the water and the wind across the Atlantic, there's a deficit of water level at the eastern side of the Atlantic. And so what it needs is it needs to be replenished. And so waters fill up from the lower levels of the ocean, which are much cooler, which creates this bubbling up of cool water. And then that flows down as part of the current. And and then the cold one going around the Southern Ocean, well, their land masses don't go as far south as the Northern Hemisphere go north. And so that's actually that westerly flow between what would be the St. Helena high in the South Atlantic and the polar low on Antarctica. So that's that westerly flow pushing. But it stays cool because there's no landmass to heat it up. So it's just a constant cold flow. We can zoom in on that though. And there's actually there's a few more currents around the ocean than there is on that larger scale drawing. And I think it's quite useful. Maybe not everybody, but a lot of people here are probably relatively familiar with the Atlantic. You may have even visited some of these places. You may have sailed in some of the places. And so it's kind of nice to know what's actually happening. And one thing you've probably talked about is the Gulf Stream. and that being the reason why the UK is warmer than countries on similar latitudes. And you can see in this picture, you go straight across to the west, then we're, well within, northern Canada, which gets pretty cold. Well, the Gulf Stream is number 1 on this numbered of the currents. Some of you might know them already. Rather than asking for them, I'll just go through them one by one. But number 1 there, that is the Gulf Stream coming out of the Mexican Gulf. And number 2 is not a continuation. Well, it is a continuation of the Gulf Stream. It's not called the Gulf Stream. It's actually the North Atlantic Drift. So that is what keeps the UK warmer than other places, the North Atlantic Drift. Number 3, also coming off the Gulf Stream, is the Azores current, and that's following round that Azores high. Number 4, back up to the north of the UK, that is the Norwegian current, coming off the top of the Scottish Isles and up the Norwegian coast. Also turning off that North Atlantic Drift is number 5, the Irminger current, which feeds the Irminger Sea, which is just to the west of the number 5 arrow, which is very, very good fishing grounds because it mixes with that cold current that comes down from the north between Iceland and Greenland, which we will get to. Number 6, I've already told you, the Canaries current, and I've already explained why it's blue and cold. Number 7 is the equatorial current. That's just from our trade wind easterlies, and they're pushing everything across to the west. Number 8 is the Caribbean current, continuation of those easterlies, and then filling up that Mexican Gulf. Number 9 is a counter-equatorial current, so still a warm current. And what it's doing is something very similar to what's happening in the Canaries. Something has to replace all the water that's been pushed across from east to west. So it's that counter-equatorial current. There'll be another one on the other side of the equator as well. Number 10, East Greenland current, driven by the polar easterlies. And number 11, the Labrador current, also driven by the polar easterlies, but pushed down south because the landmass stops it from going to the east. So yeah, how many did you know? Share it in the chat if you want to be brave, and yeah, we'll carry on. So that was ocean currents. I'm not going to do every single ocean because we'll be here all night, but we now know what's happening with the global winds. We now know what's happening with the global currents. So we can bring all that together and we can look at how that determines our ocean routing. I'll start with the North Atlantic, where we just were, and we can combine all of the effects that we know. So here I've got the Azores high and the winds going around the Azores high, out of and clockwise, and a high in the northern hemisphere. Below the Azores high, I've got the trade winds, the easterlies, the northeasterlies. North of the Azores high, I've got that polar low, which is pulling in cold air from the north, which is coming from that cold polar easterlies and driven by the polar high sitting on top of Greenland, and also driven by those warmer southwesterly warm wet winds, airflow coming north in the Ferrel cell. I just happen to think of the cell name there. And then that whole thing is driven up towards the west-northwest, and that polar low, which forms in that kind of northwestern corner of the North Atlantic, pushes it across and into the UK. We can then think about, okay, where were our ocean currents in this? I'll just go back to, well, our ocean currents were kind of following what those winds were doing. They all kind of match up. And so we get given something like this. If we want to route ourselves around the Atlantic, then we want to go clockwise round the Azores high. We want to make use of the trade winds to get ourselves across the Atlantic from east to west. We want to make use of those westerly winds and the Azores High to go from west to east and then up to the UK. If you're doing something like this, the Atlantic Circuit, then the other thing we have to be aware of is TRSs, which are tropical revolving storms, which are known to us in the North Atlantic as hurricanes, elsewhere in the world as cyclones and typhoons as well. They determine when it is safe to cross the Atlantic. Just for the purpose of this, I'm just going to tell you that the North Atlantic hurricanes occur between May and November, or June and November. And so that kind of means that we don't want to travel westwards in the North Atlantic into those lower latitudes during that time. I would thought about putting them into this live session, but I figured I'm not going to fit it all in. So I'm doing another live session. This is a great chance for a little plug here. Doing another live session all about TRSs next month. So look out for that one. But for now, if we were in the UK and we wanted to sail to the Caribbean and back to the UK or something similar, we're looking to leave the UK sometime in July, get down into Biscay while it's nice and calm in the summer, explore that Portuguese coast going into August, making sure that we're kind of down the south of Portugal, south of Spain by the time September hits and we get these autumn storms. We can then look at getting to the Canaries sometime in October, getting ourselves way south before the North Atlantic storms kick into fruition. We then don't want to leave the Canaries until late November because, as I said, it's still going to be hurricane season. So we need to stay in the Canaries till late November. We can then go straight across, or we can get south out of that Azores High. You maybe even might want to stop in the Cape Verde as well. Gets you across to the Caribbean for Christmas time, end of December. You've got this end of December, January, February, March, April. Good 4 months to explore that whole area of the Caribbean, Central America, the north of South America, if you're brave enough. And then we can't go on that next route north and east up to Bermuda or across to the Azores until the winter storms have stopped. So we need to let them die down. But then we pick up those westerlies that I said between the Azores High and the Polar Low. We get fast-tracked across the Atlantic. We're on the Gulf Stream, the North Atlantic Drift, all the way across. We don't have to go to the Azores. We can peel off further north. Depends where our end destination is. Once you get to the Azores, you can then go Mediterranean, Portugal, Spain, France, and the UK from that way. So yeah, hopefully that makes sense. That would be a year's circuit of the Atlantic. I always think everybody gets focused on the Atlantic circuit and they forget some amazing cruising grounds to the north of Europe, of the mainland Europe and the UK. Again, early summer, you're looking at the blue arrows, you're making your way north, April, up to the higher reaches of Scotland, waiting for those winter storms to finish. And then if you wanted to do kind of Norway, potentially up to Svalbard in that top northeastern corner, then you'd be heading up the coast of Norway May, trying to get to the north of Norway into July, and up to Svalbard into July. Middle of July, you need to get end of July, start of August, you're thinking you want to get out of Svalbard before winter starts to come. So you need to get yourself back south to Norway. Maybe you've still got time to get across to Iceland, or maybe you think, you know what, I'm going to be super adventurous. I'm going to go across to Jan Mayen, which is that little dot to the northeast of Iceland, and then you can go into Iceland. Iceland itself, that's pretty safe all summer, so you could jump up from the Faroes earlier on in the summer, maybe May, June, spend June, July cruising around Iceland. If you wanted to, July middle of July to middle of August is your window for eastern Greenland. You've got about 4 weeks if you're lucky. The arrow that goes north to nowhere, that's Scoresby Sund. That's the largest fjord in the world. And then the other two and back on eastern Greenland there's a bunch of other fjords around there, but there's a small town called Passelak there. You can get across there, get some provisions in before you come back across to Iceland. And then before August is out, you probably want to be getting back southeast, back across to the UK, down the east, down the west coast of the UK, before the winter storms come in. If you're coming across quite late, you probably want to be going down the east of the UK, so you're protected from all those winter storms coming across. So, and that's all driven, again, by our winds and the currents. So that route up to Norway, that's the Norwegian current. The route from Svalbard down to Iceland, that's the polar easterlies, your East Greenland current. That's all that kind of stuff bringing you down. That's the polar easterlies bringing you back across from Norway to Iceland. And that westerly airflow allowing you to get to from Iceland and also up to Norway as well. Getting back from north, from certainly middle of Norway back, it's quite hard because you're into the wind, because you're into those westerly airflows. Globally, you're probably just thinking that's just a bunch of arrows on a screen, but all those green arrows, they are our currents. They're all our ocean currents. And all the red arrows that I've added in there, that's all the ocean winds. So we're going back to the southeast, northeast trades, the westerlies coming across, and the polar easterlies. And you can see that they're doing a lot of a similar thing. And you're thinking, right, how's that going to allow me to make best use to sail around the world? Well, we just used our knowledge that we've gained tonight on the global air masses, how they power the global winds, how they then power the ocean currents around the world. And we can then think, right, I want to go this way around the world, so this is how I'm going to do it, or I want to go this way around the world, so this is how I'm going to do it. There's two ways to go around the world. One way is west, one way is east. This is how we go westwards around the world. We start off in the UK. Sorry to be UK centric. You can start this anywhere. You'll just change your time of year and the place on the chart that we start. We do that half of the Atlantic circuit, gets us to the Caribbean for the end of the year, and then we carry on heading east. We get to the Galapagos. We go through the Panama Canal, Galapagos, across to French Polynesia, enjoy all the islands. We keep traveling. Did I say east? West, sorry. We keep traveling west, and we're always in the equatorial currents and the trade easterlies. So it's the winds and the current are pushing us west. We keep going north of Australia, south of all the Asian islands there, and then we get to the middle of the Indian Ocean. We've got a choice. We can head up through the Red Sea. It's not the safest place to be because you've got to get around the Horn of Africa. So you've got the choice to go up through the Red Sea and out through the Mediterranean, or you can dip down round south of Madagascar and into South Africa. You've got a little bit of a trouble in getting around the south of Africa. There is actually a current that flows westwards around the south of Africa. The Agulhas current comes down around there, and it's powered against westerly winds. So you can get some pretty rough conditions. But once you're around that into Cape Town, you're then picking up that St. Helena high, which is going anti-clockwise in the southern hemisphere, and that allows you to bring you across to St. Helena, back up into those southeast trades of the South Atlantic, and back up into the Caribbean. And then you complete your Atlantic circuit again. So that's how we would sail westwards around the world. That circuit, without stopping, you probably need 2 years to complete it properly, because you need to wait for the TRSs, as I said. So you have to, and you've just got a long distance to travel as well. But you can't just sail it non-stop, because you will encounter TRSs if you do that. And there's times to avoid. To learn more about that, as I say, come and join me in the middle of October. Or we can go eastwards around the world. This is how all the main round the world races generally go. And we just get out from, but let's go with France this time, because that's where most of the round the world races go from. They come out of France, they get south on to the Canaries, and then they pick up that Azores High, the trade easterlies. They make best use of them, but they can't just head straight for South Africa and cut the corner, because the St. Helena High is in the way. So they have to come round that anti-clockwise St. Helena High until they pick up those Southern Ocean westerlies. Then they can get on that Southern Ocean conveyor belt, head all the way around south of the Cape of Good Hope, south of Cape Llewellyn, south of New Zealand, all the way to, you do a final dip south to get round the Cape Horn, and then you can come back up north. This time, you just have to accept the inevitable that you're going to have some upwind against that St. Helena High. It's never too bad in the South Atlantic. And then you pick up the trade winds. They then push you out further west into the North Atlantic. So you kind of cross over your path twice in doing that. And then once you're round and past the Azores High, you can shoot yourself back into Northern Europe. And even with that little delay in the middle, I've managed to get to the end. So yeah, thanks very much for listening to me. Hopefully you found it interesting. Hopefully it has been something useful for you. I know I've probably had to talk quite quickly to get through all that. But yeah, thanks very much for bearing with me.
Thanks, Stu.
Yeah, no worries.
As always, belting. Done well.
Okay, Charlie, when the house bears about 270 degrees.
Information to work out our distance from the lighthouse and use that.
We might be perfectly on track, but if we're not on time...
Have a look, I've got my phone here at the effects it has on our steering compass. So our echo sound is working, we can find a contour and follow it nicely into port.
Our left hand is pointing towards the center of the low.